The term dimensions is used a lot, whether it be 3D movies or the 4D tesseract. But what does it mean to have dimensions? And how can scientists call time the fourth dimension? To be concise, dimensions are the minimum number of values required to define the location of an event. For example, in this 2D graph over here, we'd have to mention the x-axis and the y-axis values to find any point, no matter the location. Similarly, if we were to shift it to 3D or 3 dimensions, we would also have to specify how far along the z-axis the point is located. The simplest way to explain why time is the fourth dimension is because you would also have to mention how many frames into the animation we'd have to go in order for someone to find this particular event. For example, this point that is located over here appears only after this specific point in time. Therefore, for someone to locate this point, they would need to know the x location, y location, the z location, and finally the frame number after which it appears. But let's take a deeper dive into what exactly a dimension is. In certain literatures, dimensions have a loose correlation to the amount of freedom a point would have. A single point is called zero-dimensional as it cannot move at all. A line is one-dimensional as a point needs to change only one value as it moves along the line. Allowing a point to change two values lets it move in 2 dimensions, which actually spans a plane. Similarly, a cube is 3-dimensional as a point can move about 3 different values. This is where the fun begins. How do we now trace out a 4th dimension? Remember that point in 1 dimension that could move anywhere on the line? This actually means that the line was a set of all the 0-dimensional points placed back to back. Similarly, the plane was a set of all the lines placed together, while the cube was a series of planes placed on top of each other. So, if we were to take any 3D object, move them and then record that movement and place it with the previous forms of the objects, we would get the 4th dimension. Imagine you are that 3D object. Every time you change your position, you are forming a new version of the 3D object. So you need a dimension to allow that change. That dimension is time. To make any change, you need to move through time. Just like the way we have to move through different frames of this animation to change the positions, sizes, or rotation of objects. However, this then feels like a more basic dimension than the 3 previous dimensions we spoke about, as changes in any one of those dimensions still require this 4th dimension that we are calling time. For example, the point on that 1D line would still need this dimension to move through the line. Therefore, we separate the 3 previous dimensions as spatial dimensions and call this 4th dimension the temporal dimension, and always refer to it as the +1 dimension. That is, our world is a 3 + 1 dimensional world, which means 3 spatial and 1 temporal. This now brings us to the question of higher spatial dimensions. The tesseract is a 4-dimensional cube, a hypersphere can be a 4D sphere, and so on. In all these shapes, the 4 dimensions are spatial. What does that mean, and how do we represent them? To understand this better, it's easiest to drop the dimensions and take a look at an example. Imagine this flatland creature who lives in a 2 + 1 dimensional world. It is unaware of the 3rd dimension and cannot see into it. If we were to introduce a 3D object into this 2D world, it would be able to see only the 2D slice of the entire object. Although what exactly it sees deserves another video, for now we will understand that it experiences a circle for this sphere. As we move the sphere, the size of the circle grows and shrinks, which is strange for the flatlander, but makes sense to anyone viewing the 3rd dimension. Also, take this 3D object and imagine flatland move through the 3rd dimension. The flatlander sees a square move forward and backward. This is analogous to time being that +1 dimension that allows movements. So, in case of these 4D shapes, us being in 3D would only see the 3-dimensional cross-section of the 4D shape. A 4D sphere would appear as a 3D sphere, growing or shrinking in size as time passed, and similarly, the tesseract would look like a cube that changes its shape over time. Newer theories like the string theory demands higher dimensions, with the M theory requiring 10 plus 1 dimensions to be present. An explanation towards why we can't experience those dimensions is simply because we are too big, and these dimensions exist only in the smallest of scales around the Planck length, which is in the order of 10 to the power minus 35 meters. An example would be this one-dimensional line. If we zoom in enough, we see that it's actually a 3D rod. So overall, at the end of the day, dimensions are just mathematical tools used to help explain the various phenomena we experience in our day-to-day lives, and also solve the questions that we have related to the fundamental laws of nature. The exact intuition and meaning can vary based on the context and just the overall way you choose to understand them. But the result will always be the same, and dimensions will always remain an important way to view reality. Thank you so much for making it to the end of the video. The concepts explained here might have been a bit abstract, so there will be more videos on the same topic coming out soon enough, with other methods of viewing what dimensions are, and also what fractional dimensions like 1.5D or 1.32D would mean. So remember to stay tuned both here on YouTube and on Instagram, and share this video with everyone you know to add a dimension to their understanding of dimensions. Until next time, stay tuned, stay safe, and be ready to keep learning.